All right, here's number 3. Now number 3 is a little bit tricky because our center of curvature is going to be kind of a mess. So we're at about 2.9 centimeters from the center. Remember, we're going to measure from the center of the focal point to the front edge. See, that's about 2.9 centimeters. And so we're going to go 2.9 centimeters the other side. And this is actually the ray that's most likely to be off because you actually measured where your center of curvature is. Alright, so remember, going back here, the pink one, our first ray is going to be in pink in my world. Okay, whatever color you used for your first ray, continue using that. So we're going to go in and out through C, which is really tricky for us to do because we're going to line up the top of the object with the center of curvature, and it's not going to hit the mirror. So if you want to make, if you want to extend your mirror out that way, that'd be fine. So we're going to line up the center of curvature with the top of the object. And we're going to go in and out through C. Now it comes back down this way because we actually don't know where it's going to meet up right now. So we know it's going to meet up somewhere on that line, but we don't know if it's going to meet up here or if it's going to meet up down here. Alright, our second ray goes in parallel, out through the focal point. So we're going to line this up and we're going to go in parallel. I find it easier if I put my ruler on top because it's easier to see the parallel. If you have a see-through ruler, that's even better. But you're going to go in parallel. Okay. And then from where it hit, you're going to line it up with the middle of the focal point. And you're going to go out through the focal point. So we know our image is somewhere around here where those rays meet. Our third ray is going to go in through the focal point, out parallel. So we are going to line up the top of the object with the focal point and then go hit the mirror. In through the focal point. And then from where it hit the mirror, we're going to go out parallel. Okay, they didn't quite meet up perfectly, but they met up pretty close. Yours may or may not. Depends on how well you measured this. Depends on how parallel your parallels are. It's how many times have you done it? Cut yourself some slack. And then our last ray is our protractor ray. In through the vertex, our angle of incidence equals our angle of reflection. So here's our vertex. We're going to line the top of the object up with the vertex, draw a line. And you might want to bring this back just because it's our object is so close. You may not be able to measure this if your ruler is bigger. So bring it like way back here, in through the vertex. And do you see how that made it easier for me to measure? So I'm going to line up my protractor so that the spot is there and 90 is lined up with 90. And this again, okay, it's not always going to be 8 degrees, but this time I got 8 degrees again, but it's not always going to be that because like on the next one it's a lot bigger. So mark 8 degrees on the other side. And then you're going to line up the vertex with the dot you made. And it should meet up close to the other 3 rays. There we go. And then we're going to draw in our image from the principal axis to where they meet. Okay, So our image again is inverted. And because it's inverted, it's real. And it is magnified. And we can tell it's magnified because if we measure this guy, he's only like 0.7 centimeters long. And this guy here is 1.6 centimeters long. So the image is bigger than our object. And we're going to find that if your image distance, I'll write it down, if your image distance is bigger than your object distance, so if your image is further away from the mirror than your object is from the mirror, then it is also magnified. That's another way you could tell. All right? Onward. Flip it over.